Hi guys, Mr. John here. In this video we're gonna take a look actually inside of this multimeter, which is a UNI-T UT56 multimeter, as you can see. Now, a little prehistory to this meter. This meter is quite old. I bought it back when I was in school actually, and now it's been well over 5 years since I left school. I got bachelor's degree. Now I'm getting to receive master's degree. That's not the point here. By the way, the specialty that I study is not strictly electronics engineering, if you might ask. I'm gonna kill it off right there. So this multimeter is quite old. I bought it when I was at school, as I mentioned already. I actually went into the store and with buying a meter in mind. I wanted to buy a meter, but they had quite a variety on the shelf, and this meter was, if not on the top of the line, was very near it. I paid 400 for it. Of course, not dollars. Don't freak out yet. I don't clearly remember the exchange rate back then, but roughly that was 40 bucks or probably more. So decent. Actually, when I bought it, I was like 16 or 17. I don't remember. So a young fella walks in and points a finger at the almost the most expensive meters I have to offer. The seller was like, what do you need that meter for? And that's the only phrase I heard from him. Anyway, yes, I freaked him out, but meh, whatever. I'm quite proud actually for my choice, because this meter is quite good. It is only 2000 count meter, as you can see from the ranges, but it's pretty good, as I say, as I already bragged. It can measure DC voltage, you can see there, AC voltage. It has this useless range where you can measure the gain of the transistor, AC current, DC current. AC current was something the cheap meters did not have. Something like DT830, which I had previously to this. So in comparison to DT830, this was a huge improvement. I mean, like, huge. By the way, it can measure up to 20 amps. The leads get very hot. As you saw in my switch mode power supply video, 18 volts, 20 amps. I had actually to do a little patch because the cable actually just broke in half shortly after I did that. It also has capacitance range from 2 nanofarads to 20 microfarads tops. Has a pretty decent resolution there. As you can see, that's 1 picofarad, so it goes 1/10 of a picofarad. And as for the milliamps, there we go. We run 2 milliamps, so that's microamp. So we have 100 nanoamp resolution, which is excellent, I think, for a 2000 count meter, because all the other meters I have, like this one here, is also 2000 count meter. But if I'm gonna go and switch that to, well, this one has 20. It's in DC current, 2 milliamps range. See, it only has resolution down to 1 microamp. By the way, the current range here does not work. I forgot to mention that in a previous video, but it doesn't work because one of the shunt resistors inside, 9 ohms, one to be exact, is open for whatever reason. Maybe it was like that from the factory. But yeah, I like this meter because it can measure quite low currents even being on 2000 current meter. As you can see, 2 milliamps range again, 100 nanoamp resolution. May not be all that accurate, but still, it's a nice thing to have. Then it can measure frequency. Just picks up some hum, I guess. Usual continuity diode test and the resistance from usual stuff. Can actually measure up to 200 megohms, which is very nice. That's why I'm not too bothered about AN8008. I did not even twist my tongue there. Many of you do, which is fantastic. Anyway, thing is that AN8008 meter cannot measure anything above 10 mega ohms, which is not a big problem because I have this bastard here. And actually this one can do the same. And the third one I have, oops, let's try to not flip the camera out. Can only go to 20 mega ohms, but it's still pretty good. Here we go. That meter, by the way, acts as a counterweight. That's why the camera tilted. Alright, and in 200 millivolt scale we have 10 microvolt resolution. Pretty good. Still, the reading will be perfect zero if I'm gonna short the probes, and of course it's gonna help if I'm gonna stick him in the right place. But let's take a crack inside and see. This meter is the largest of the three I have. It has this nice holster, which for one reason protects it from impacts and stuff like that. The other thing I like about it is that it's rubber, so when you set it, drag it on the table, it doesn't make that annoying plasticky sound that, sorry for the shaking, that this one makes, because this one has no holster. Versus this one. Very nice. As for this meter, I showed the guts of it in a previous video, so I don't see why that will be interesting for you now. But this one is currently the best meter I have, hands down, because you may just laugh your ass off, but I don't care. It's made by UNI-T. That's the best brand I can afford. Actually, I took a peek on at the range of their multimeters, and I cannot afford anymore anything decent from their range anymore. So that's why I took a look at the AN8008, but you bastards started to throw feces at that meter, which is clearly aimed for hobbyists, and it does that extremely well. Yes, it lies about cat ratings, but so what? You should expect that from the price. Speaking of cat ratings, this one has only... oh boy. Sorry for that. This one has only Cat 1 rating, 1000 volt max. I'm not a pro here, but I think the higher the number in the Cat rating, the stricter the requirements are, right? So this one is rated reasonably low, so I have a feeling it might actually pass if you do these tests. And on the back side we have a few more ratings. Cat 2 600 volts, which is I don't know. I don't think it will pass Cat 2, but Cat 1 I think it will pass. This one doesn't even say about cat ratings. I like that. Why lie? Why bother? Right, so let's dive into it. The screws, by the way, are self-tappers here, which is annoying because the battery is hidden under the main cover. So it's not the easiest meter to change the battery on. Luckily the battery actually lasts a long time here. And I should probably speak louder because the microphone in the phone is nothing but deaf. It's not really all that great. I have to speak rather loud in order for it to hear me well. So 3 self-tappers, crackety sound, and what do we have on the inside? A board that doesn't look half bad. I did not clean this board, it was like that from the start. Pretty much no flux residue if you ask me. Very clean. Has this spring which connects to the missing screw, to the shield there. Has this bodge capacitor there, which is trying to 160 volt, 100 nanofarad. This is obviously the input divider network. Not a thin film or thick film, whatever. I think that's just a bunch of precision resistors in series, but still a good thing. Oh, and we can hoik it out. So that's we see on the other side. It has this E-clip there, which prevents the dial from falling out. And on the other side we see a beauty, if you ask me, because if you take a look here you won't find any surface mount part whatsoever. Everything is done purely through-hole style. And let's make sure it's in focus. Yes, it is. Here we have a couple of ICs we can straight away recognize: 20nano4, LM20nano4, LM358. These are very similar op-amps. They differ by the maximum power supply voltage. This one can go up to 24 or something like that. This one can go up to 30 volts on the supply rail. Here we have a JFET input TL062 op-amp. Again, dual op-amp, JFET input. Nothing fantastic so far. Here we have the TL062 again. The chip you see there is 7555, which is standard 555 but in a CMOS, made with CMOS devices. And that's pretty much it. It uses this metal film. Actually, let me disconnect the battery before I short something out. It has this metal film resistors all over the place, which is quite nice, as you can see. This, which look like one or probably tighter precision. The fuse, by the way, is 10 amp range, is, well, 20 amp range actually, is not fused by any means. Well, it is pretty much fused by the means of this track, but, or the leads. The track doesn't look discolored or anything, it looks perfectly fine, even though you saw in the previous videos that leads are pretty much nuckered. So the board is reasonably well made. God damn, I hate when that happens. Okay, so the board is reasonably well made, so far. Here you can see the reasonable size shunt, which is huge in comparison to what other meters have. This side is very boring, isn't it? We have our on-off switch. We have a hold button. We have our... It may not be a piezo, it may be just a sounder kind of stuff. Here we have a multi-turn trim pot for some calibration means. Usual trim pot. Some volt ohm, how that is called? Diode volt ohm hertz input is protected by... Well, oh, I'm lying. Milliamp input, this one, is protected by means of this fuse, which is, to start with, is at least the long one. So I don't think 1 kilovolt will easily jump across it, because A9AN 8008 meter has a very tiny fuse which 1 kilovolt will jump over. I completely agree with that on that, so have no doubts in that. This one, not so much. If it's clean, if it doesn't have some fingerprints on it, it may be pretty good. Of course I ain't gonna even bother checking how good the layout is, because I don't use the meter on that kind of voltages anyway. Soldering looks fine, by the way. Okay, next thing I'm gonna do is I'm gonna pop this screen off, and under that you will see big deep packages. You can see 1 row of pins there, and under it there is another little deep package, 8-pin package. So let me do just that. Sorry for these sound effects. It's getting pretty cold here, so I might actually move to that little corner in the house from this lovely shed where I can make a racket, explosions, a lot of smoke and whatnot. Let's try to not lose the zebra strip. Ooh, it's tight. Set it there. Nothing fantastic there, right? Set it away. And under this, you see a maxing part. Oh, come on. ICL 7129 ACPL. And if I'm gonna move that hoik Z out, you will see another little package. But you can see the footprint there, right? So I have no need to hoik that chip off, because the socket will wear out and will do weird stuff. I don't want to do that. This meter is really, as I already told you, laugh how much you want, but this is the best meter I have so far. I was very tempted. Okay, I run out of memory. The phone is again. I was very tempted to buy a meter, but as I mentioned, you started throwing feces at that meter, and the seller that I bought it from appeared to is scam artist. So yeah, I get a fake tracking number. I did not receive the package, obviously. I told the eBay to go kick his ass, and eBay did just that. So that's a huge thumbs up to eBay there. That's why I like that website. They received my message, and they did what they said they will do. They gave me a refund within a predetermined period of time. So again, thumbs up to eBay, great job. Have nothing to complain about. And that's that. Pretty much this couple of... This is just a transistor there, nothing fancy. C9014 NPN transistor, that device there, C9015 PNP transistor, right there. Nothing fantastic, right? There's a couple of chips there, as you saw. Here's one more look at it. And I'm gonna pack it here because this video is getting quite large already, because I had 18 minutes of possible video links on the SD card, and that collapsed, as you saw, and now I'm saving this file onto the memory of the phone, and I don't want to clog that, so I'm gonna call it here. You saw what's inside. Leave your comments thinking about how poor my ass is. Alright, and that's it. Thanks for watching. See ya.